Hello everyone. Today we start coloring of graph in discrete mathematics. So what is coloring of graph? So coloring of graph is an assignment of colors to its vertices such that no adjacent vertices have the same color. So as we know, in graph there are two things. First one is set of vertices and second one is set of edges. Set of vertices is represented by V and set of edges is represented by V. That's why we denote the graph as G equal to V comma E. Okay, so just like this. So mathematically, suppose G equal to V comma E is a graph with no multiple edges and C is equal to C1, C2, Cn is the set of n colors. Then the vertex coloring of G is a function from function f from B to C such that adjacent vertices have different colors. That is, if Vi and Vj are any two adjacent vertices, then function of Vi is not equal to function of Vj. Okay, so there is a word adjacent vertices. So how you can see here, if we have a graph like this, so we can see here there are four vertex and four edges here. So which vertex are adjacent to each other? You can see here. Adjacent vertex means that if there is an edge between two vertices, then these two vertices will be adjacent to each other. That is, if we talk about V1 and V2, so there is an edge. So this edge is an these vertices we call adjacent vertex. Likewise, this one V2 and V3 also adjacent, V3 and V4 also adjacent, and V1 and V4 also adjacent. But if we talk about V1 and V3, these are not adjacent, and likewise V2 and V4 are not adjacent. Okay, so if we want to color this graph, so you need to think that remember that if you color this with green, then you have to color this with different color. Okay, suppose it is yellow. Okay, if it is yellow, then you can color it by green. Okay, if it's green, then you can color it by yellow. And you can instead you can see here that no two vertices, no two adjacent vertices have same color. So there are only two colors for proper coloring of this graph. Okay. If we talk about if we have a three vertices graph like this, then how many color we need to color this graph? Okay, if we have a vertex V1, V2, V3, so we can color it. If we can color it by green, then we have to take different colors. Okay, also different colors. So this is the way of color. Okay. Suppose we have another figure like this. Okay. Then how to color this one? So you can see. If we color it yellow, then we cannot color it yellow. So we can color it by green. Okay. Also, these two vertices are adjacent to each other. So need to take different colors. So you can take it yellow. Okay. You can take it yellow. If you color yellow, then you can take it green. Okay. And you have to take different color to color this. So you can take it red. So you can see no two adjacent colors, no two adjacent vertices have the same color. So this is the way to coloring the graph. Okay. Now we move to chromatic number. Chromatic number, the minimum number of colors which are required for proper coloring of a graph. It's called chromatic number of the graph. Okay, so a graph that's need a different colors for its proper coloring and no less is called K chromatic graph. Okay, that is the minimum numbers of colors which are required for proper coloring of graph. It's known as chromatic number. Okay, for example, you can see if we have a graph like this. Okay, so you can see if you color it blue. Okay, and you can not color it blue with blue, but you can color it by yellow and you can color it by yellow. You can take color it by blue, you can color it by blue, and also you can color it by yellow. So only two color needed to color this graph. Okay, think only remember one thing, that no two adjacent vertex have the same color. Okay, so if you see another figure like this, like so, this vertex is adjacent to this and this. It means if you color it red, then you have to take different color. You can take it yellow or green. Okay. If you color green, then you can take it red. Okay, and you can take it green. So there is only three color required. So chromatic number for this one is 2 and this one is 3. Got it? So this is K3 graph and this is K2 graph. Is that clear? So let us do one question properly, and which is very much important for the point of examination. Let me start. What is the chromatic number of the following graph? Okay, this is the figure and we need to calculate the chromatic number of this graph. Okay, so you can see how can we solve it. Since vertex A, B and F must are in different colors because these are adjacent to each other. Okay, so let me write it. There must be at least three. So we have to check whether three colors will be sufficient. Color the graph. Okay. Now suppose we assign green color to A, red color to B, yellow color to A. Okay. Then we cannot color we can color G with green. Okay. Because G is adjacent to B and F. Okay. Likewise, this is adjacent to B and G, so we cannot color it by red and green, but we can color it by yellow. Okay. Likewise, E is adjacent to F and G, so we cannot color it by green and yellow, but we can color it by red. So D is adjacent to C and E, so we cannot color it by yellow and red, so we can color it by green. Okay. So this is the way to coloring the graph. So there is only three colors need to color for proper coloring of this graph. So its chromatic number is three. So let me write. Okay. So suppose we assign green to A, red to B, and yellow to F. Then G can be colored green. H it is adjacent to B and F. Okay. Further, C can be colored yellow. H it is adjacent to B and G. Okay. Let me remove from here. So similarly, E can be colored red, and tea candy color green. So this complete the coloring of the given graph. With exactly three colors. Okay, so chromatic number is 3. Okay, so this is all about chromatic number.